So here's a problem where things go a little bit backwards. Rather than being given a concentration and finding a pH, we were given a pH and asked to find a concentration. Now this isn't all that unusual, because in reality we measure pH with pH meters, and then from that we need to calculate concentrations, and that's pretty much what we're doing here. We do have a new equation that we're given that relates pH and hydronium ion concentration. It's just the opposite of the calculation that we use to calculate pH from a concentration. And we see that we're also given Kw. So the first thing we want to do is we want to calculate the concentration of our hydronium ion. And so hydronium, H3O plus, that's going to be equal to 10 to the minus pH, so 10 to the minus 1.9. So you would use your 10 to the x button in your calculator. And so when we work that out, we get a value of 1.26 times 10 to the minus 2. Now, that's my hydronium ion concentration, but what the problem is looking for is what is my hydroxide ion concentration. Well, we need to use our equation for Kw. We know that the Kw is H3O plus times the concentration of OH minus, and that's equal to 1.0 times 10 to the minus 14. So we plug in our value for hydronium, and so we have 1.26 times 10 to the minus 2 times the concentration of OH minus. That's got to be equal to 1.0 times 10 to the minus 14. And so when I work that out, I get a hydronium ion, or a hydroxide ion concentration rather. It's a terrible bracket. There we go. Equal to 7.94 times 10 to the minus 13.